Hello and welcome back to the course on deep learning. Today we're talking about contractive autoencoders. This is going to be a very quick tutorial just to introduce the concept, and then we'll advise some further reading where you can dig deeper into it. So, contractive autoencoders. This is another regularization technique, just like sparse autoencoders and denoising autoencoders, which is designed to combat the problem when we have an complete hidden layer in the autoencoder like we have here. So the problem we have is that the autoencoder can just simply take the inputs, copy them into the hidden layer, and then copy them into the output without actually learning any valuable feature extraction in its training. And that's what we wanted to do. We wanted to be able to extract features. And so what the contractive autoencoder does is it leverages the whole process, this whole training process, where information goes through the autoencoder, then we get the outputs, and then they're compared to the inputs. Well, contractive autoencoders, they add a penalty into this loss function that's going back through that's being propagated back to the network, and it specifically doesn't allow the autoencoder to simply just copy these values across. How it works, we're not going to go into detail on that because it is very complex. There's quite a lot of math behind it, and we're just going to recommend a wonderful article here by Salah Rifai. It's called Contractive Autoencoders, Explicit Invariance During Feature Extraction. And what I also wanted to mention is that this article has quite a lot of authors, has I think 5 authors, and one of them is Yoshio Benjo, so quite an in-depth study into the topic. So from this tutorial, the takeaway is that there is such a thing as contractive autoencoders, and based actually on this article, they say that they can even get better results than denoising autoencoders on some certain data sets. And so it's just important to be aware of the fact that contractive autoencoders exist. And if you ever need to dig deeper into contractive autoencoders, or if you would like to learn more about them, then this is the best place to get started. This specific paper by Salah Rifai and others, including Yoshio Benjo. And that's it for today. I look forward to seeing you next time. Until then, enjoy deep learning.